So we're going to do chapter 18, number 30. Now for chapter 18, number 30, they're telling us the electric field is 160 newtons coulombs. They don't tell us the directions, but we're just pretty much going to assume the directions because at the end we need to find another electric field, but they don't care about that direction either. So we have an electric field of 160 newtons per coulomb, and for the moment we're going to assume that it's going to the right. Now because it's going to the right, we're going to assume that the charge creating this is some kind of positive charge. And they tell us that this electric field is located 0.14 meters from this charge. Then they want us to find the electric field strength of located 0.45 meters from that same charge. So we need to find this electric field here. Now, the way we do this is, alright, we need to figure out what the electric field is, but it would help us if we knew how big that charge creating the electric field is. So we look back to the electric field that we know, and we know that electric field is equal to KQ, which in this case Q is the charge creating the electric field, divided by R squared, which in this case is 0.15. So when we actually plug in all our knowns, we can solve for Q, and we get Q is equal to 4 times 10 to the negative 10 coulombs. Using that Q, we can then try to find our orange electric field that is 0.45 meters away. So we can use that same equation, E is equal to K, source of the charge, divided by R squared. So we know that K is 8.99 times 10 to the 9. And we know that the charge we figured out was 4 times 10 to the negative 10, divided by the distance squared. And then when we plug everything in, we find our electric field to simply be 17.78 newtons per coulombs. And again, if we had drawn this a little differently, that's fine. The direction might have changed based on how you drew it, but in essence, the question was just asking us what is the electric field magnitude. It didn't ask us for what the direction was. But it would be the same direction as the original electric field.